Hi children, today I am going to present to you the third video of the topic differentiation. Before we move further in this topic differentiation, let's try to understand what do you mean by a gradient of a curve or a straight line. We know a curve or a straight line perform an angle with x-axis. If we measure the tan value of that angle, that is exactly defined as a gradient of the curve or a straight line at that specific point. Remember, always that angle should be measured with the positive x-axis. Hope you can understand what you mean by positive x-axis using this diagram. Let's try to find the gradient of the straight line which passes through the 2 points A 1 3 and B 4 6. From previous slide, we came to know that the definition of the gradient. The gradient is the tan value of the angle performed with positive x-axis. We know that from our IGCSE contents, tan x is equals to opposite over adjacent. From this diagram, we know that opposite is the height performed in the triangle and adjacent is the horizontal length along x-axis. Therefore, opposite turn up into difference of y coordinate and adjacent turn up into difference of x coordinates. Then simply tan x turn up into difference of y coordinate divided by difference of x coordinates. That is how we get the definition gradient equals to y1 minus y2 divided by x1 minus x2. From this question, if you substitute the coordinates of point A and B, we can understand the gradient turn up into 6 minus 3 divided by 4 minus 1, whereas it has turned up into 1. From this diagram, there is another special point we have to concern. We get a positive gradient. Now children, concentrate on this diagram and understand if you get a positive gradient, what kind of a graph you get. This is another example to find the gradient. Here, the line passes to 2 points A and B, where A is 1, 6 and B 4, 3. If you use the same principle, gradient equals to y1 minus y2 divided by x1 minus x2, you can realize that gradient turn up into minus 1. Here, we need to understand when you get a gradient as a negative value, what kind of a graph you get. This is a third example. If you get a line which is parallel to x-axis, what kind of a gradient you gain? If you use the same principle, you can realize that gradient is equals to 0. So hereafter you have to understand that if the gradient is 0, there the point is parallel to x-axis. This is the fourth example. There the line is parallel to y-axis. If you use the same principle, you can obtain that the gradient is infinity. The reason is that numerator is 5 but the denominator turn up into 0. As a result, if any number divided by 0, that is called the infinity or it's undefined. Therefore, you have to understand that if you get a gradient infinity, we have to understand that there at that point, the line is parallel to y-axis. Let's try to reform the theories what we have learned from previous slides. If you consider the gradients at specific points, you can understand that at point A, with that angle, you have to understand that the answer must be a positive value. At point B, it's a bending over point. At that point B, you have to understand that it is parallel to x-axis. Therefore, the gradient at point B should be 0. And point C, you definitely you must get a negative value. The reason is that angle is defined in a way you get a negative value. Again, if you reach to point D, that point also parallel to x-axis. Therefore, the answer at the gradient D should be 0. Then if you define with E, you have to understand that there the curve is parallel to y-axis. Therefore, the gradient must be infinity. From our first video, we have already learned the purpose of learning differentiation is to simplify with the problems involved with gradient. Therefore, let's try to understand how to find the gradient using differentiation. To find the gradient, follow up these steps. Initially, differentiate the original function. That gives you the gradient function. Then after that, substitute the coordinates of the point in this differentiation function. That gives you the gradient at that specific point. Let's try to find the gradient in this example. The question is, find the gradient of the curve at the point A, 1, 10, whereas 1 is the x coordinate and 10 is the y coordinate. For the function y equals to 10x to the power 9 plus 2x to the power 6 minus 2x squared. Step 1 is to differentiate the original function. If you differentiate y equals to 10x to the power 9 plus 2x to the power 6 minus 2x to the power 2, you will receive 90x to the power 8 plus 12x to the power 5 minus 4x. Now you can understand that this dy by dx answer is a function of x. That means it includes only x terms. Now what you need to do is you have to substitute the coordinate. In the substitute the coordinate, we need to substitute x values because you need to understand that the differentiation function is a function of x. Therefore, if you substitute 1, you will receive the answer 17. That means the gradient of the curve at point A would be 17. If you use the same principle for example number 2, the function is y equals to minus 3x to the power 5 plus 4x to the power 3 minus 2x squared, you will receive the answer minus 3784. Hope you have understood. In previous examples, we came to know how to find the gradient of a curve at a given specific point. In this slide, we need to learn if the gradient is given at a specific point, how to find the coordinate of that point. Step 1. As usual, the gradient is involved with the differentiation. Find the first differentiation. That means you need to differentiate the original function only once. Step 2 is equate the first differentiation answer into the given gradient. That gives you the x coordinate of the specific point. Now we know the x coordinate of the point with the given gradient. If you want to find the y coordinate, you need to substitute this x coordinate into original equation. Let's try to understand the theory from this example. The question is, find the coordinates of the point on y equals to 3x squared plus 4x minus 2 where its gradient is 18. That means on this curve there is a point. If you measure the gradient of that point, that is 16. We need to find what is the coordinate. You have to follow up the following steps. Step 1. Initially you have to differentiate. If you differentiate 3x squared plus 4x minus 2, you will receive the answer 6x plus 4. Step 2 is equate that first differentiation answer into 16. That means 6x plus 4 equate into 16, you will receive the answer x equals to 2. That means the x coordinate of the point with gradient 16 is 2. Now if you want to find the y coordinate, what you're supposed to do is substitute that x coordinate into the original function y equals to 3x squared plus 4x minus 2. That receives you the answer y equals to 18. That means the coordinate of the point with the gradient 16 is 2, 18. Let's try to verify this principle from the second example. The question is, you need to find the coordinates of the point on y equals to x cubed plus 3x squared minus 25x plus 1 with the point of gradient minus 1. If you differentiate this function, you will receive the answer 3x squared plus 6x minus 25. And it's given that gradient is minus 1. Therefore, you can equate 3x squared plus 6x minus 25 into minus 1. Then this perform into a quadratic equation. 3x squared plus 6x minus 24 equals to 0. If you simplify this equation, you will receive the answers x equals to 2 and x equals to minus 4. That means the x-coordinate of the points with the gradient minus 1 is x equals to 2 and x equals to minus 4. As what we did in the previous question, we need to find the y-coordinates as well. To find the y-coordinates, substitute x equals to 2 and x equals to minus 4 in the original equation y equals to x cubed plus 3x squared minus 25x plus 1 separately. If you substitute x equals to 2 into the original equation, you will receive the answer y equals to minus 29. That means one point with the gradient of minus 1 is 2 comma minus 29. If you substitute minus 4 into original equation, you will receive the answer y equals to 85. That means the y coordinate, means the second y coordinate with a gradient of minus 1 is minus 4 comma 85.